The first project I would like to share with you is the low temperature cold-fired ceramics, which is as known the LTCC development. So this work we collaborate with our partner A3. So the goal of this project is we try to develop a low dielectric constant and low dissipation factor LTCC because these two kind of properties are preferable for 5G applications. Well, but the issue of this kind of topic is the development of LTCC includes very complex and multi-dimensional inputs. So this includes these two parts. The first thing is the glass compositions, and the second thing is the processing parameters. So it is therefore very, very difficult to modulate the properties via trial and error method. So the strategy of this work is we try to build up machine learning models for predicting dielectric constant and dissipation factors. And in this project, the output, of course, is the dielectric constant and the dissipation factors. And the input can be characterized into two things. The first thing is the glass compositions, so which you can see here, very complex different kind of glasses. And the second thing is the processing parameters, which includes different kind of calcination temperature or even calcination time at different stage. So we have total 9 inputs, and the total number of data set was 63. So the model performance, as you can see in these two figures, the left-hand side was the dielectric constant for the parity plot, and the right-hand side shows the dissipation factor. So you can see the R-square was quite okay, like this is for 0.82 and this is for 0.99. And all the root square error versus the standard deviation of the dataset was less than 1, so which is shows a good or even a good predictive uh, ability of these two models. So by using this kind of method, machine learning method, we have built up a machine learning function of glass composition and process parameters to the dielectric constant as well as the dissipation factor. So this shows the true or the measured one, and this is the predicted one, and for this part, it's the same. So to further evaluate the performance of a model, we can try to use this kind of cross plot. So in this red point was the measured data point. This is for dielectric constant, and this is for dissipation factor. And you can see in this black line shows the model predicted value. So you can see the value, the model predicted one agrees well with the measured point. As well as here, even we have a little bit deviation from the measured one and predicted one, but you can see the trend still agrees very well. So this is not only we can see the model performance, the predictive ability, or the interpolation ability, but we can also see, for example, this is from different glass space. This is from the corduroy space to the alumina space. So if we want a low decay, low dielectric constant LTCC, we may want to design the composition toward the lower, toward the corduroy composition as well as this in these things. So this also guides us how we can design our recipe for the LTCC. So in order to control the signal delay and the energy loss in the LTCC for the 5G applications, so which is our goal. So by following this paper guidance, we know that the DK or DF value should be lower than 10 and 2 times 10 to the minus 3 respectively. So by using this kind of criteria, we try to plot this kind of property contour plot with respect to 3 different kind of glass compositions. So you can see we can divide it into 2 different kind of region. The one is the red The red one means this composition, glass composition fulfilled both criteria of these two, the 10 and this DF value. And if this is in blue, this means we only fulfilled one of these two. So if we want to have a low dielectric constant and low dissipation factor LTCC, we can try to have the recipe which lies on this red region. So if we have a glass composition on this region, this means we fulfilled both the low DK and DF value. So this can help us to very quickly design the new recipe of LTCC. And this work has been published in some materials in this year. So if you need more information, you can visit our paper.